Okay, so we're going to go and do 2-4 as an ed puzzle. As you know, you're in ed puzzle right now, so genius for me to start by saying that. But it's really a standalone section. It really goes with our looking at our calendar. Kind of a mistake to bring this up because I probably don't even have it up there, but this really belongs with the very first day that we came back. Just solving triangles in general. SOHCAHTOA. It is kind of strange, but it's not bad. Really exercises some ideas that we should remember. Um, in order to function further with circ, or tic. So this is definitely SOHCAHTOA. The ability to solve a triangle and some things that we should know. So sometimes you're going to be given drawings and sometimes you're not. So it really is important to probably make a sketch as an aid, but really understanding that this isn't just side BA from here to here, side BA. This also could be called side lowercase c. So just being able to remember that. Angle B is here, side B is across from it. So that's how they number or label their sides here today, not with two letters, but with one lowercase letter. A is opposite A, B is opposite B, C is opposite C. So sometimes the triangle will be drawn for us, like our first example. I'm going to dive right into it. Kind of got my examples side by side here, but first example is when we're given a couple angles on the side measure. By the way, we are in right trigonometry, or right. Whoa, what was that symbol? So we have a right triangle. So we can do SOHCAHTOA, hypotenuse and all. And that's what we have here. We have the hypotenuse. But one of the first things that we can find is angle B. Obviously, we know in a triangle, all angles add up to 180. And I already have 90, and I already have 3620. Okay, now just remember, and I don't have a calculator with me. I guess I have one on my phone. But how to break this down, and I'm going to verbalize this because we did this in the last chapter and actually quizzed you on this. But so let's see, 54 degrees. 50 plus 30 is 80, so 54 degrees. Oh wait, that's too much because that would be 90 degrees in 20 minutes, right? So again, I'm doing this subtraction, but I'm doing it in my head. So I have to borrow a degree, not really borrow a degree, but now that's 89 degrees in 20 minutes. And then all I need is 40 minutes left over in order to make up that 90th degree there. So just knowing how to work with minutes and understanding that 40 minutes plus 20 minutes is 60 minutes, which is that extra degree. So these two add up to 89 degrees, 60 minutes, which is 90 degrees. 60 minutes is 1 hour. So 60 minutes is 1 degree. Whatever you want to do it. If you did it with your calculator, you'd have to turn decimal back into minutes, blah, 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 blah. Okay, now I would stick with the original. I have this original right here. What sides do I have? Well, let's start with A. Let's start alphabetical. Well, that's opposite. And then this is the hypotenuse. This is Y. This is in. Or we did this the very first day that we came back. A over, 964. Sorry, a little slow on that. Now, when you go to your calculator, remember you're going to multiply both sides by 964. So it's 964 sine, and then this is what you're going to type in your calculator. 36 plus 20 over 60. All right. And then I can probably show those answers when we're done here. Then letter B, flash to my old notes. Letter B, this is adjacent and hypotenuse is given. So that is cosine, or I guess I won't put it that way. It's a little out of practice after the 3 or 4 day weekend. Cosine of 3620 equals, because cosine's ka, 964. So going back up to here, what it says, in order to solve for a triangle, you find all of the unknowns. So I had to find all three missing parts of the 6. Then, of course, B equals, of course, my pen stopped working, just randomly in the middle of writing. B equals, multiply both sides by 964. And then on your calculator, you'd type 36 plus 20 over 60. Okay, then I'll do the next one and then maybe pull my old notes and show what those final answers are. My old work. Okay, and then this one, we have two sides given and no angle measures. So we have actually a bunch of ways we can go about doing this. We know this is a right triangle. So the first thing that we could find is C. This is the Pythagorean Theorem, 12.5 squared, A squared, plus B squared. Actually, yeah, A is 12.5. That's funny. Side opposite A is A. Side opposite B is B, just like I covered it. And C is opposite C. 16.2 squared. And then that equals C squared. And then you square root this. And we'll show what those answers are here shortly. All right. I just don't have my calculator with me. So, and then let's change colors just for fun. Let's find angle A. Well, when we look at angle A, this is the opposite side. It's always a good idea to use what's given too. What if you made a mistake on this? Then that would be an incorrect side value used for the next step, which would make that incorrect by default. So it's being careful there. Opposite over adjacent is tangent. What you do is you take the tangent of A. Make sure your calculator's in degrees. And that is 12.5 over 16.2. Then changing colors again really won't let me write that too. I don't know if green really sticks out compared to blue, but we'll do it anyway. When we circle B, this is the opposite side. So now I got to change that to opposite, and this is adjacent in green. When I'm doing the green question or trying to find angle B. Oh, and by the way, how do you solve for tangent of angle A? You inverse tangent both sides. So you inverse tangent this 12.5. Thank you. Love you, computer. 16.2. And then angle B, tan of B, because it switches who's opposite and who's adjacent. 16.2 over 12.5. Or, of course, you could find angle A and then take 90 minus that. Because you already have 90 degrees with the angle C. There's only 90 left over for A and B. So once I find A, you could just do 90 minus. But I often like to do the trig because it doesn't take that long. And then if these do add up to 90, then I really know I'm correct. At least feel good about it. Okay. I'm going to risk going to my notes, the old ones, and show what those answers end up becoming. Boom, boom, right here. So there's the two answers for number 9. There's that sine 3620. Didn't really show how to write it on the calculator there. That's all good. And then here are the two angle measures with the inverse happening. Oh, and then nice of me to do this. What if they wanted it in degrees and then minutes? Then you would take this 0.35 and multiply it by 60. All right. And then you'd take this 0.7 and you'd multiply it by 60. Okay, so these should add up to 60 when you're done if you round appropriately. Then you round to that nearest minute. So I believe in the directions, yes, give angles in degrees and minutes. Okay, so make sure that you do that, degrees and then minutes. Okay, going back to my regular notes. Boom. Yeah, we're trying to separate the cat e-learn from our regular cat. In the old days, if ever things get back to normal, then we can go back to our normal, a little bit lengthier notes. All right, and then here's the problem when you don't have a drawing. Make a drawing, but also read the question, solve each triangle In each case, C is 90 degrees. And it also says give your angle in degrees and minutes. I'll show that answer at the end. So I always draw my triangles the same. I don't really care about 13 and 22, trying to make those look proportional, like compared to the side measures, compared to what their lengths are. But I got to make that C, and then I couldn't care less who you made A and B. Once you do that, angle A is here, side A has to be here. This is why you draw your stuff, because if you don't, then you won't be able to play SOHCAHTOA correctly without visualizing what's the opposite and adjacent side. All right. So first things first, won't like insult you by asking you in the Ed puzzle about the Pythagorean theorem, but just don't make a mistake. It's 13 squared A squared plus B squared equals C squared. So then it's B squared equals whatever these two subtracted are, and then square root. And I'll show that answer when I show the completed notes just for the calculations part of this. All right, I wouldn't use B anyway to find angle A and then angle B. Angle A, this is the opposite side. This is the hypotenuse. So yet again, it's another question which I think sometimes can be a little bit more challenging, or students make a mistake on solving. This is one we have to find an angle, which means you have to use inverse sine. So A equals inverse sine of 13 over 22. What? 13 divided by 22. All right, and then just sticking with the spirit of the colors here, and then when I switch to angle B, this is the adjacent side and still the hypotenuse. So angle B, yet again, is cosine of angle B equals 13 over 22, which again, that's an inverse. So knowing when to do that, that should be already taken care of from our Wednesday of the beginning of the year notes. Okay, we'll hop to the old ancient notes, maybe. Okay, and then verify what those answers are. Boom shakalakers. Okay, so looking and showing that you inverse sine both sides. All right, get 17.7 meters for the Pythagorean theorem work, and then degrees, then minutes. I decided to put a decimal minute on there, which is probably a smart decision there. So we inverse sine this, we get 36 point something. Take the point something and multiply by 60. Shouldn't be rocket science at this point. And then yeah, same thing. Okay, 53 point something. Take the point something and multiply by 60 to get the minutes parts. Alrighty then. And then finishing off, should be pretty easy puzzle, just SOHCAHTOA. This is review again. Okay, maybe on that Wednesday I ran short because Wednesday is a short day, but I told my students to watch the remaining of the video for angle of elevation and depression. And I think I have this cut out again because even though it was old Math 2 notes, I used some cat notes to describe. But then also, and this is what's big, look at, be careful when interpreting the angle of depression. Even the book, my cat book, well, we aren't cat, knows this is the big problem. Both the angle of elevation and angle of depression are measured between the line of sight and a horizontal line. So an angle of depression, I'm looking down. This is not the second angle or second side that makes the angle of depression. This is like 75% of the students make this mistake. No, it's looking down and horizontal, just like angle of elevation, looking up and a horizontal. No one misses angle of elevation. Majority misses angle of depression. And then in our notes, I talk about the dog and the bird, and only those that watched and do what they're supposed to do did look at that. So let's just say you're up here looking down on me, and I'm down at the bottom. Okay, so here's my angle of elevation. Let's just use the eyesights. I'm looking up to you. But my angle of elevation, you need a second side. So that's an angle of elevation. And almost nobody misses that. They always draw correctly that it's based off of a horizontal. All right. And then I'm going to change colors, and green and red are good. Here's your angle of depression looking down to me, but then horizontally out. And that's what people mostly miss. And then what I've said, and it's not the first time, an angle of elevation looking up is equal to the angle of depression of someone looking down to you, because these are alternate interior angles with the sides, of course, being parallel, right? This side is definitely parallel to that because they're both horizontal. So oftentimes when I look at an angle of depression question, I always think of the angle of elevation and make sure I have it in the right spot. But I would never make that mistake because I've done this for years and talked about this for years with students, and still I get like 75% of the students get this wrong on a test. Angering. All right. Shelley McCarthy, I love this book. It's always very specific with the last names. Knows that when she stands 123 feet from the base of a flagpole. So the ability to read that, and what is that marking on our drawing, kind of very important. The angle of elevation to the top of the flagpole is, but then they make a point. If her eyes are 5, so what they're making a point here is that's where the angle of elevation starts from. Starts from her looking. So she's got the machine like at her eyeball. So the angle of elevation, they have those machines. You ever see those people out there? I think they're getting elevations of the ground when they're using those machines out on the road when you're driving by. But so we got Shelley McCarthy. Again, not big on the drawings here. And it's her line of sight. So, okay, fine. She stands 123 feet away from the base of a flagpole. So here's the flagpole. And then there's the flag. Okay, so that is 123. But then we got to incorporate what they said in this question. The flagpole is straight up and down, or vertical would be a math word there. So this is 123. And then this is 5.3 because she's 5.3 feet high. So that's kind of cryptic. I don't know why Shelley doesn't have any arms. We get an eyeball. All right. No mouth, though. All right. So now her angle of elevation. It's like her line of sight, but a machine can actually measure this. So there are those things out there. So the machine gives that angle of elevation as 26 degrees, 40 minutes. So not or 40 minutes. Yeah, not degrees there. Now, so this is what we got. So what we need to find is this x, and then the final answer will be this is the height of the flagpole. Pretty simple. So what trig function would we use, and what would the numbers be? This would be a perfect little Ed puzzle that we'd put together there. Give that applause for Mr. Samuelis to make that Ed puzzle question. Boy, couldn't give you more of a warning on that one. All right, so now the answer. Well, that is OPP, baby, you and me. And then this is the adjacent side. Used to be in a song back in the, I think, 90s. All right. Tangent would be the choice. And then 26 degrees, 40 minutes. And then we'll write what we'd have to write on our calculator. Luckily, x over 123. And then we just have to multiply both sides by 123. So what you type on your calculator is 123 times tan, and then parentheses 26 plus 40 over 60. Most direct and easy way to deal with degrees. Okay, I'll jump to my notes again. Should have had a more prepared, but I don't care. This works. Where's the Shelley McCarthy question? Boom. All right, so you get tan 2640. Again, told you how to type this, 40 over 60. That's 61.77, but the whole height of the flagpole is plus 5.3. Okay? All right, so just be careful of that one. Typing and then getting the correct answer there. All right, and then the last but not least, angle of depression. So warned you about it. Make sure you make the right decisions here about how to draw this. So the angle of depression from the top of a building to a point on the ground. Okay, so you got a building. Not going to get all fancy with our drawing. And obviously, we're at the top of the building. So the angle of depression starts at the top of the building. There's no human looking on this. So no tricky with the Shelley McCarthy situation there. But here's the problem. People draw this angle of depression. They draw the line, like the line of sight. Okay, fine. I'm looking down from the building. Then almost always, this is the 75% of the students, they just have an itch to put it right here, that angle measure. And it just isn't right. You must complete the angle of depression with the horizontal, okay? Looking out horizontally. Same thing with an angle of elevation. Angle of elevation looking up, but then the second side is looking horizontally out. Why does no one miss this? And almost everyone misses this. Oh, Mr. Samulus. So many years of seeing those mistakes. This is 32 degrees, 30 minutes. And 30 minutes is nice. I don't know why I kept putting a degree mark there. That's 0.5 of, so 32.5 is the angle I could use there. All right, now let's read from the heavy. How far is the point on the ground from the top of the building? It doesn't say the foot of the building or the base. It says how far is to the top of the building. So this is what we're finding, the direct distance from the top of the building to the point on the ground. By the way, if I was looking up to the top of the building, then this would also be 32 degrees, 30 minutes. If that could help you and save you something just to get this angle of depression correct so I get more people on board on this. All right. How far is the point of the, if the building is 250 high? So this is 250. If you want to create and make a rectangle out of this, this is 250. We can use that. All right, good. Get your trig ready. Okay, so what are you going to use on this one? Let me make sure it is signed. Okay, opposite for sure. And this is the right angle. We assume the ground is horizontal. The building is almost always vertical, unless it's the Leaning Tower of Pisa. This is the opposite side, and this is the hypotenuse. Opposite over hypotenuse, sine. Sine of 3230. Ooh, good. I think this is the first time I remember putting this in a video. Equals, it is 250 over x. I don't think so. I think I did cover this in the other video back 2 weeks ago on a Wednesday, maybe 3. I forget where we're at right now. But these two can switch. What I do is multiply both sides by x, then divide by sine blah. So x equals 250. Let's try to write this like a calculator. And it would be okay if you wrote 250 divided by sine, because it's going to divide by whatever you type next, the sine of, and we already have the parenthesis there. If you didn't know 30 over 60 was 0.5, then this is what you'd type physically and then press enter. But these two switch positions is really all that happens on that whenever you have a variable in the denominator. Multiply both sides by x, then you divide by sine. So that's what ends up happening. Okay, final answer. I didn't do that one. Oh, here we go. So I drew all my crazy stuff there, but you can see the switching and the dividing. Oh, and I was lazy and I didn't even calculate that. So you calculate that on your own. Have fun with that. Been a pleasure.